And welcome back to learning and preparing for the Linux Plus exam. In fact, these next couple questions will help you not only for the Linux Plus, but the Security Plus, the CISSP, some other security exams, Network Plus. And these are from my book that I published with Sander Strohmeyer, Preparing for the Linux Plus exam. You can actually have a chance of winning a free copy of this book, a free digital copy. Just make sure you like, subscribe, and comment, and you'll be entered into a contest. And we'll do this drawing on October 16th, 2020. And let's go ahead and get started with the questions. And the first one is, which of the following is not a single sign-on system? Our choices are Radius, Kerberos, Tac Plus, Circumference, and LDAP. You can pause this if you want to think about it. But the answer here is D. There is no single sign-on system called Circumference. And single sign-on systems are AAA protocols. AAA stands for Authentication, Authorization, and Accounting. And when we look at these systems, they allow you to have and get access into a network. You log in once, and now you have access to the entire network. So it's also known as IAAA, where the I stands for identity. That would be your username. And then A would be authentication, so then you can put in your password. And then authorization would be the rights that you have to the what are called objects. And objects in general would just be the files or network resources. It's a general term. So do you have read-write access, read-only access? Do you have the right to make changes? And then finally, accounting is keeping records of all your work. And so accounting would be what they also call logging and monitoring your activities. You'll find that several companies use single sign-on systems. Probably the most popular are Radius and Kerberos. Radius offers a dial-in service. Tacacs and Tac Plus are pretty well just for Cisco only, and then LDAP gives you access to a server similar to Active Directory. And that's it for single sign-on. But it really makes life convenient for an individual because now they don't need to have a separate login and password for each system that they're working with. They can just have one single login, one password, and it gives them access to the entire network of resources at the company or organization. Now let's take a look at number 34. So like I said, these questions would be good for a lot of different exams, not only the Linux Plus, but even the Network Plus and Security Plus and even the A Plus, as well as the CISSP, some of the ISC squared exams. Consider the following IP address, 172.17.8.10/22. Which subnet mask is assigned to this address? And so I'll let you go ahead and think this over. Press pause if you like. Otherwise, the answer to this one is A. Let's go ahead and take a quick look at how we get to this. So if we look at a subnet mask in networking, the mask is what separates the network from the host. So for example, if we have one of the options was 255.255.0.0. Wherever the zeros are represents the host on that network, and wherever the values are raised, that represents the network on the network. Now if we take a look at doing a quick conversion and what this 255, what that means. This is in decimal values, but in binary if we do a decimal to binary conversion, 255.255.0.0 in binary comes out to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now if we look at this, there are 16 ones. So this network would be called /16. That mask would be called /16. They call this CIDR notation, classless internet domain routing. All right, CIDR spelled CIDR. But this 255.255.0.0 is equal to /16 in CIDR. We have in the question /22 in CIDR notation. Well, /22 in CIDR notation would be /22 would equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 1, 2, 3, 4, 5, 6, 7, 8. See, there are 8 bits per octet. 8, 8, 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits per octet. Now the question is, and we can always answer this question in reverse. So we know that if the values are all ones, well, we know that B is not going to be the answer because that's going to be 16. We know C is not going to be the answer because that's going to be 24. So for example, if we said 255.255.255.0, that's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, which is 24 ones, 24. So we know that that's not the answer. And we know that D is not the answer because we already had 24 ones, and then we're adding 252 on that. So by default, just by not even doing any math, we know the answer is A. But how did they get this 252? Let's talk about that real briefly. The way they get 252 is by, now let's take a look at this value here. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to create a new page here. To go from binary to decimal, when you have 8 bits, we can do a little trick here. So we had 1, 2, 3, 4, 5, 6, 7, 8. The way this works is when you have 8 bits, each location has a value. This would be 1, we're going to double this 2, we're going to double this 4, 8, 16, 32, 64, 128. And wherever the value is set, we use it, and wherever the value is not set, we don't use it. So for example, since these are, wherever we have the ones, we're going to say 128 plus 64 plus 32 plus 16 plus 8 plus 4, and since these are 0, we're going to say plus 0 plus 0. And if you get your calculators out, this will be 252. So that's how we get that value, and you can go forward and backwards using this technique, going from binary to decimal or decimal to binary. Alright, so that's it for questions number 33 and 34. Again, we want to say thanks for watching. I hope you understand what we did there. And again, remember to like, subscribe, and comment if you want to enter our contest. Drawing again will be the 16th of October 2020. We'll see you at the next video.